All right, I've now installed the majority of the bulkheads onto the top. I thought you might be interested to see the process, so I saved this last one to take a picture of here. And since we want to make sure that the fuselage is square, it's important to make sure that the bulkheads are indeed vertical in relation to the top of the fuselage. So I use the square. I butt the square up against the edge of the top. Then I butt the bulkhead up against the square. Then I use another small square that I made out of a piece of plywood to hold it in place. And I just tack glue it down on one corner with the thin CA to make sure that I don't glue the triangles in place, and then hit it full width on both sides, and then give it a quick spray of the accelerator, and it's in shape. And that way we know that the side of the fuselage will be indeed perpendicular to the top. Now here is a fuselage side, and what we'll do next then is to lay the fuselage side up against the top and the bulkheads as I have it shown here, and then just take the CA and run down all of the joints as we work our way to the front. All right, now I've completed the assembly of the sides and the top of the fuselage to the bulkheads. So all we have left to do now is to put what's actually the bottom of the fuselage onto it, and that'll lock it into a quite a rigid structural member. Now you can see the carbon fiber on the piece that I'm going to use for the bottom, and the carbon fiber is going to be on the inside so that it won't show, and it'll also be protected, more structurally efficient on the inside. So the way I'm going to do this is to use the slow drying CA glue, put a bead on all of the structural components that are going to be touching the bottom cover. Then I'm going to spray a light coat of the accelerator onto the bottom piece itself. Then I'll put them together and get a good bond. So I'll go ahead and do that, and when we come back, the fuselage assembly will be complete, and I'll have it off the board. Okay, now we have finished the main fuselage subassembly, or the tail boom, the boom part of the fuselage. And as you can see, we've left a slot for the pylon. The pylon fits in there nicely, and we won't mount the pylon permanently until we get the rest of the fuselage completely finished, including covering and doping. We'll cover the pylon and dope it. We'll have the engine mounted and the timer mounted, so that we can then locate the pylon fore and aft, such that the center of gravity is where we want it to be. Now, in this case, we want the center of gravity to be at the 60% of the wing point. So we'll mark that on there, and then when the fuselage is complete, we'll balance it with the wing and the tail on the airplane, and we'll adjust the pylon fore and aft until we get the balance point at the right place. So the next step then is to put the rest of the fittings on the fuselage, and they consist of the cheek blocks that go one on each side of the fuselage to build it up to accommodate the diameter of the engine. Then the 1/8 inch plywood firewall will be added to that. then we'll shape the fuselage to round off the cheek blocks to match the firewall. Then on top of the firewall goes the landing skid mount, and as you can see, the landing skid is bent up out of 1/8" wire. I use 2 coils, and then I bend an L in the top of the landing skid. The L then fits into a slot that I have cut on the landing mount. The mount is first glued to the front of the fuselage, then the landing gear skid is epoxied into that slot. Then when the engine is mounted using this engine mount, that clamps that landing gear in place so that it can't escape. It makes a good solid landing gear mount. The back end of the fuselage requires the addition of the stabilizer mount, and then the center fin will be added. I've continued the construction of the fuselage boom, adding the horizontal tail support and the cheek cowls and the firewall at the front end. But at this point, there were a couple of things that I wanted to show you. The first is how I key the horizontal tail to make sure that I get a good alignment. It's particularly important on this particular model that you do get a good alignment of the horizontal tail, because it does have rudder tips or fins on the tips of the tail. And as you can see, the tail has 2 keys, one front and one rear, which need to be aligned so that the tail is properly aligned with the direction of flight. So what I've done is I have cut a slot in the stabilizer rest for the front key, and I've cut a large hole in the rear so that I have room to move it around. And then I take a piece of plywood with a tight-fitting hole in it, slip it over here, and then position it, align it, and tack it down. So when I come back, we'll be ready to do that, and I'll show you how to do it. Okay, now we're ready to actually do the alignment, and this is where the line down the center of the fuselage becomes important, because that's the primary thing that I use to assure alignment. This is the slot, little piece of plywood with the slot in it for the rear key, and I'll put that over the key, and then we'll put it in there. The slot for the rear key has enough room in it so that I can slide the plywood in and out and get it positioned generally aligned where I want it. But now comes the critical, and what I use is a large drafting triangle, which I'm going to position on the fuselage, lined up with that line that I drew, and I'm going to tape it lightly using masking tape to the leading edge of the stabilizer. And get it in 2 places out here, because I want this to be lined up with the leading edge and held against it, so that when I position the other edge of the triangle along the line, down the center line of the fuselage, I get the correct alignment. As you can see, the tail is free to rotate slightly, a few degrees, so I can position this right there, and I'll hold that. Then I'll slide this little piece of plywood in there. And then I'll take the thin hot stuff and I'll just tack down the rear of that piece of plywood. and that'll hold it in place. In alignment. It's positioned properly now so that the tail is correctly aligned. Now I can take the tail off and then go back and permanently glue that rear key platform in place. So we can stop here, and when I come back, then I'll have some fiberglass pieces cut out, and I'll show you how I go about fiberglassing the front of the fuselage. What I've done is I've taken a piece of fiberglass cloth, drawn a circle on it such that, you know, it'll overlap the nose by 3/4 of an inch or so. And the way I fiberglass is I put one circular piece on the nose and then fold it back. Then I'll take another strip of fiberglass and wrap it around this way. And that gives me double coverage on this joint that I feel is quite critical, which is the firewall joint to the fuselage. And once I get the 2 layers of fiberglass on there, this front end will be quite solid and really, really tough. So let me just cut this circle out that I've drawn here. The cloth that I'm using, I believe, is about 2 or 3 ounce grade cloth, and it's quite adequate for this size of a model. If you start going to the heavier grades, it gets a little bit difficult to bend around the corners and hold it. But I'll show you how I put it on and get it to stay in place while I'm adhering it. Okay, there's the rough cut circle. I'll put it down here and give it a light coat of spray cement. And that will allow me to stick it in place on the model and get it to stay. Okay. Then I take the scissors and I cut slots in it all the way around. This will allow it to overlap and make a smooth contour. Then I just start at one place on the diameter and lay it down, taking each little petal at a time, making it lay out smooth, and the spray cement holds it in place very nicely while I spread it down. You'll notice that I'm covering right over the slot for the pylon. That doesn't matter because we'll be cutting that out again to clear it for the pylon. But during the fiberglassing process, just lay the fiberglass right down over the slot. Okay, that's the first piece on, and I'll go ahead and adhere it. Typically, or in the past, let me say, fiberglass has been always adhered with some kind of a resin, either polyester or epoxy. But again, from the tapes on how to use the Satellite City products, I followed their suggestion rather to just use the thin CA glue as the adhesive for the fiberglass, and it works really super because you're done in a flash. And what I do is I'll put one coat on, and you just kind of hold the surface at a 45-degree angle and let the thin CA just run down and fill in the weave of the cloth. You notice that I put the plastic glove on, and that's because I rub it down to make sure that it adheres as well as it can. The reason for that is that the CA does dissolve the spray cement, and if you don't rub it down while it's hardening, it's possible that it can pull up on the sharp corner going around the edge. Now, usually I do this gluing outside because it gives off lots of fumes. All right, I'm just finishing up feathering in the overlap of that first layer that wrapped around the corner. I've got the blank cut out for the other piece, so let me spray that with the adhesive and we'll put it in place. Just a light coat, as is always the case, holds it in place very nicely. There are several advantages to using this technique of the thin CA glue to adhere the fiberglass. One that I mentioned, of course, is the speed and ease with which it can be done. Another one, of course, is when you're sanding it, you don't get any of the sticky fiberglass dust kind of activity. And I think that's because the CA totally saturates the material, and so there's no loose fuzz to get loose and get into your skin. And of course, that's an important consideration too. Fiberglass is a very loose weave, of course, and you can pull it very nicely and make it lay down on compound curves and around the front. And it's also very easy to remove the excess, like if you cover over this slot for the pylon, it's simply a matter of, after you put the first coat of the CA glue on, you can just take the knife and slice it out. It cuts out very nicely. Then the second coat that I mentioned toughens it up. Got that thing doubled over there. I guess that's going to overlap the slot, so we'll just go ahead and lay it down. You want to rub out, get it smooth, pull it out so that it lays down smoothly. Okay, it's all tucked down nicely around the edges and so on, and I'll just go ahead and put the thin CA on there, and that'll take care of it. I'll after I feather the edges in and so on, I will then put another coat of CA, rubbing it smooth with my fingers in the plastic glove, and that'll take care of the fiberglassing, giving me a very tough and strong front end. Now we're ready for the last step in the assembly of the fuselage, and that's covering it. I use silk on the fuselage primarily because it adds considerably to the strength and durability. The fuselage is where you're going to do all the handling of the model, and it takes a lot of abuse. So silk has proven to be a very good covering material for this purpose. It turns out that silk is also one of the easiest covering materials to use too, although not too many people use it anymore. I think the secret to covering with silk is to cover with it wet. Now, to prepare the material, the fuselage and the pylon for the covering, I have put on 2 coats of sanding sealer and sanded them smooth to take off the grain fuzz. It also provides water protection so that when I wet the silk, the wood won't soak up a lot of water. The way I start out is to take a strip of silk that I've cut and lay it on the part to be covered. Take a little bit of dope and tack it down at one end. Now, if this were a wing, you would tack it down along, let's say, the root rib. And then when that has a chance to set for a couple of seconds, straighten the silk out. And I'll take a spray bottle with water in it and just spray it down. Get it pretty wet. Now, you may have, I don't know if the camera picked it up, but the silk was wrinkled from where it was folded in the package. But that's really no problem because when you wet it, those wrinkles just melt away. Now, when you're covering with silk, one of the important things to keep in mind is to try and keep the grain of the silk, that is the threads of the silk, in as straight a line as possible. It's not quite so important when you're covering a solid wood area like the fuselage here, but when you're covering open framework, wiggly lines in the grain will show up and detract from the appearance of the covering. You can use the dope brush to just kind of tap the silk into place, into little hollows. Here I'm trying to come down on the angle behind the cheek block. One thing to watch out for is longitudinal wrinkles. In other words, I have pulled the silk out lengthwise, and consequently there's a tendency to develop wrinkles that run this direction. So what you really need to do then is to go over and smooth out any of those wrinkles. I mentioned earlier that silk is probably one of the easiest materials to cover with, and I say that because it drapes so beautifully. It will cover any kind of a compound curve that you can imagine, and do it very easily. There's no problem at all. All you have to do is wet it down, and it will cover. Then you just go back and once you've got it fitted in and smoothed out, just go back and paint on a coat of dope. And in this case, I'll be working my way down the length of the fuselage. You'll notice that initially I didn't wet it all the way down. I'll, just cover a few, smooth out, and dope down a foot or two at a time until I've got the whole thing covered. The dope will go right through, soften the sanding sealer on the bottom, and adhere the silk to it beautifully. So I think that gives you the idea of the process. So I'll shut off the tape now and go ahead and finish up the covering here. Now that I've got this one side covered, it's time to trim off the excess. I use a razor blade to trim it. And I guess one thing that I wanted to mention is that it's always good to put a little dope a little bit farther out on the edge so that you have some silk with dope on it to trim. The dry silk by itself will tend to fray a little bit unless you have an extremely sharp razor blade. So, but if you got a little dope in it, it makes a nice cutting surface. So it works out very well to just trim it down the edge with the razor blade. And in this case, I'm not trimming for any lap over, because what I intend to do is when I cover the top and the bottom, I will trim the edges of the silk on the top and on the bottom using that trimming tool that I showed you when we were covering the wing. And that will then overlap the covering on the side and give me a nice straight seam. So it's, as I say, silk is really very easy and quick to cover with. The only real disadvantage of it is that it has gotten relatively expensive in recent years. Although I'm not sure, I haven't done a cost analysis on it, but I don't think that it's probably any more expensive than some of the plastic film coverings if you get right down to it. So I'll go on, cover the other side, and then the top and the bottom, and I'll come back when we get ready to start putting the extra coats of dope on it. Now that the fuselage is fully covered with silk, the next step is to put all the fuselage hardware on so that we can do our trial balance and locate the pylon. But before I go on with that, I wanted to mention a couple of things. After you first get your fuselage covered, the edges are going to be kind of rough where you've lapped over the silk. And the way you take care of that is to put a couple of coats of dope on and then sand it smooth with fine sandpaper, and then put a couple of more coats of dope on, and you'll have a essentially invisible seam. When we started putting the covering on, I mentioned the possibility of getting longitudinal wrinkles or bubbles in the silk covering. If you should do that, and if you don't see them in time until after you've put the dope on, a way to get around that problem is to take a razor blade and slit down the length of the wrinkle or bubble, and then wet it with dope, and then just rub it out smooth with your finger, and it'll become invisible. I guess one other thing that I wanted to mention is that whenever you're gluing anything to a silk covered surface, you want to be sure and cut the silk away so that you have a good wood to wood gluing surface. And in this case, I have to mount a fin on the fuselage right here, so I'll be cutting the silk away there and then probably poking some pinholes in it to make sure that I get good glue penetration to hold that on. So I'll go ahead and put the hardware on the fuselage and get it ready. All right, now I have all of the hardware mounted on the airplane. As you can see, the timer is held in by tape because I have to cut a hole in the pylon for the timer to seat completely. So until we determine how we're going to locate, where we're going to locate the pylon, I just put it in temporarily so that we can use it during the balancing process. The engine is mounted. I've even put a prop on it. I've got the fuel tank, here, and I think before we get into the balancing, I'd like to make some points about the engine and how I mount that and the fuel system and so on. If you can zoom in, you can see that the engine is mounted on using an aluminum disc. I just went to a welding shop and bought some 3/16 sheet aluminum, cut the discs out with a saber saw, and then put them on a lathe and turned them down to size and cut a hole out of the middle. This is probably the lightest way of mounting an engine that there is. The engine is then mounted to the airplane using number 4 socket head sheet metal screws. Now the sheet metal screws are going through a 1/4 of an inch of plywood there, and I've used this approach to engine mounting for the last couple of years on engines of all sizes. I've never had a problem with the screw coming loose or pulling out. Another thing that I'd like to point out is the fuel cutoff mechanism. This is just an aluminum angle with a wire guillotine, if you will, which is spring-loaded, and the timer holds it back, and the fuel line goes up through the hole, and then when the timer releases the wire, the guillotine snaps forward and pinches off the fuel line. And that, in combination with the pressurized fuel system, which I highly recommend, gives for very good, reliable, simple engine operation. So with that, I think we'll go ahead and do the balancing. I don't know if you can see it, but if you zoom in right here, you can perhaps see some index marks that I've made. Now those index marks are to tell me how much I need to move the pylon. And so when we get into the balancing of the model, I'll show you how I use those. So the next thing to do then is put the wing on. Just one rubber band is quite adequate to hold it on for this purposes, because we're going to be supporting the model underneath the wing platform. And you can see here I've made 2 supports out of some 1/4 inch molding material that I had around the house, and we can then just set the model on those supports right on the end of the bench. I just tack the supports onto the bench with some brads, and then we can just set the model down on there and move it until it balances. Now I've already marked on the platform where I want the model to balance, on the wing platform that is, and in this case it's at the 60% point. All right, there we have the model balancing fairly well. We can take a look under there and see where it is actually balancing. Okay, now we want to balance it with just a slight nose down attitude, which is what we have there. Make sure that we're properly aligned with the balance mark on both sides. It looks like we can twist it just a little bit. Okay. Now, the model is balanced properly, and the supports are about 1/16 of an inch in front of the desired balance point. So what that means is that I need to then move the pylon forward 1/16 of an inch to so that when the model is fully assembled, it will balance properly. And that's where the index marks come in, so that now I know that all I have to do is take a 1/16 of an inch off the front edge of the pylon, slide it forward that 1/16 of an inch, and then glue the pylon in. And the model will then be balanced with no addition of weight. So the last step that we have to do is the trammeling of the model, or the alignment of the wing and the tail surfaces. So we'll come back in the next scene and I'll show you how I do that. The last step in assembling the model, prior to the final painting and so on, is to align the wing and the tail surfaces. Now the tail is already aligned. If you recall, when I was assembling the tail rest and so on, I showed you how I used triangles and the center line of the airplane to get the tail properly aligned when I added those tail rest parts. Now the only thing left then to align is the wing. Now I use wing key dowels, and if you can zoom in, you can see what these are. I just take a dowel and round off the end of it on the disc sander, and then I run the dowel lengthwise through the bandsaw for a 1/4 of an inch or so, and then I saw off across the dowel the wing keys. Then I coat them with a coat of epoxy paint, and they're completely fuel proof and so on. So the way I start out in aligning the wing is I put the front, I usually start with the front locator dowels or wing keys, and I align up the center seam of the wing, the center joint, with the center joint on the wing rest or the wing platform. And that gives me then a place to start. That makes sure that the wing is located span-wise properly, and it still gives me enough play then to locate the wing in the fore and aft position. So the way I do that then, I put the wing on the airplane, with a couple of rubber bands so that it holds fairly well, but yet you can still slide it around. And I spread the rubber bands apart so I can see where the joints are and so on. Then, to make sure that the wing is properly aligned in the fore and aft position, I take and use a piece of steel cable. This is a piece of control line cable. You need to use something that won't stretch, and you'll see why in a moment here. Take a straight pin and locate it in the tip of the fin, or any convenient place at the rear of the model. Because what we're trying to do is make sure that the distance from the tail of the airplane to this point is the same as the distance from the tail of the airplane to that point. So, put the cable on there. I've put a piece of masking tape doubled over, which I can slide up and down and then squeeze it, and it sticks fairly well. And then I just slide that right up, measure to that point, and locate the tape. Then I take it over and measure to this point. And it's within a 32nd of an inch right now, and that's close enough. The importance of wing keying is to make sure that you have a consistent trim, because if the wing were twisted back, it would want to make the model turn more to the right, or if it was twisted this way, it would want to make the model turn left. So in order for consistency in the power of flight, you want to make sure that the wing is on the airplane the same way and in the same relationship every time. And that's why the wing is keyed. So now that we've got the alignment, I'll go ahead and I'll put the wing keys at the back of the pylon. Then the airplane will essentially be finished. The one final thing that I do before I fly models is I spray the nose of the model with hobby epoxy paint to completely fuel-proof the front end of the model so that it can stand up for a long time. And that fairly well completes the construction of this airplane. We will include, as the final segment of this tape, a demonstration of flying, and we'll go into the mechanics of how you operate a pressurized fuel system. And with that, I'll see you at the flying field. Okay, now we've described the engine and fuel system on these airplanes to quite a bit of length during the earlier parts of the tape. So now I thought it would be worthwhile to show you how to operate one. The way I'm going to show you is important not only for convenience and ease of operation, but also from safety. The first thing that we need to think about in safety is protecting our ears, because these engines create very high noise levels. So I always use earplugs. These are earplugs that are soft foam. You kind of roll them into a cone and then stick them in your ear. I think the brand name is Ear, E-A-R. So you always put your earplugs in. And now we'll put the fuel in the fuel bulb. That'll be the next step here. To put the fuel in, I use a syringe. And we just pull the fuel line off the engine fitting and inject the amount of fuel that we want to use into the fuel bulb, and you can see how it expands. Then I use just a squeezed spring-type clothespin to pinch off the fuel line so that the fuel does not squirt back out until I'm ready. Now we've got some other airplane activity around here. Okay, now when you're not familiar with where the needle valve should be set under pressure, an easy way to do that is turn the airplane upside down. First of all, rather, close off the needle valve until it's closed down. Then turn the airplane over, take the clothespin off, and then open the needle valve and watch for the fuel to drip out of the intake. And when it gets to dripping about where you think, and that's about right for this engine, I think. That looks about right. And then we can put the clothespin back on. That way, the reason we do it upside down, of course, is so that the engine doesn't get flooded and it's ready to start now. So, we're ready to start. To start, I think it's very important, as I mentioned, for safety and for convenience, to have a mounted electric motor starter that's operated with a foot switch. That way you can keep both hands on the airplane. You use one hand to pinch off the fuel line and while you're in the starting process, and the other hand to hold the airplane and to keep the glow plug wire out of the propeller arc. So I'll get situated here and get ready to start the engine, and we'll come back in the next scene and we'll show you the starting process. Okay, now when you're tuning an engine, it's very important to use a digital tachometer. This is a small battery-powered digital tach that I use to tune the engines on the initial startup. One thing I might describe is how you can tell whether the engines are running rich or running lean. The sound is your primary clue. If a pressurized fuel system is running on the lean side, the engine will surge. It'll go rear, 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 rear. Or if it's running on the rich side, it'll just gurgle, sputter, and gag, and it might even stop. So that's your clue as to which way to turn the needle valve. Then when the engine gets to running smoothly, you put the propeller near the tachometer and tune it for peak RPM. So we'll go ahead and start up the engine, and I'll get it tuned. I don't know if the sound, it'll probably drown out the camera, but at least you can see what's going on. Okay, the glow plug clip, in this case, I'm going to come over the wing with it and put it on, and then when I'm holding the airplane, I hold the glow plug wire so that if the clip should come off, it's blown back and it can't get into the propeller. Then I reach over and I pinch the fuel line closed with my thumb and forefinger on my left hand, reach underneath, take off the spring clothespin clip, stick the nose into the starter, pulse the fuel line once or twice with my fingers. In other words, just give it a little bit of a prime, and then step on the switch and start cranking. It's always important to check the function of your fuel cutoff to make sure that the timer will indeed shut down the engine at the end of the desired engine run. Now, so you've seen all of the process. I think you can see that it's very straightforward and actually quite easy to do, and it's quite safe because your hands and your body is always behind the propeller arc, and you're never near those high-speed propeller tips, which can really cut you badly if you should get a hand or a finger into them. So let me close down this scene here, and we'll come back and show you what a launch looks like. Okay, after that last launch, I thought maybe you'd like to see what a full launch looks like and a transition into the glide. These airplanes have a gorgeous, nice floating glide. Well, that's it. That's what they look like, a soaring glide. And I hope this tape has been useful to you. It's certainly been a lot of fun making it. And good luck, and see you downwind. An inevitable part of modeling is a requirement to repair damage. Every once in a while, through nobody's fault, the model is going to get damaged one way or another. In this case, this wing was damaged by the model gliding into a fence post on landing. And as you can see the notch in the leading edge, or you can just see the diameter of the fence post. And of course, when it hit the fence post, it cocked the wing back, and the rubber bands which were holding the wing on slid down the trailing edge and crushed in the trailing edge here a little bit at the back. So there's at least two areas that are going to require some repair. The first thing that we'll try to do is to try to fix up this trailing edge. And the way I'm going to do that is I'm going to take a syringe that I have water in, and I'm going to inject some water into the balsa wood through the covering. And then I'm going to use the sealing iron to create steam out of that water that I've injected, and hopefully it will swell the wood back out to its original size and shape. And if this then works out, as I think it is, it looks like it's doing all right, then I will inject through some pinholes in the covering and put a couple of drops of the thin CA in there to toughen up that area of the trailing edge. Yeah, it's looks like it's swelling out nicely. I worked on the bottom, now I'll work on the top a little bit. Not only do we want to swell out the wood, but we want to get the covering to lay down nicely again without showing any wrinkles. And I'm not sure that we can do that completely, but doesn't hurt to try. Okay, well that's about it. It might take a little bit more, but you see the technique and the approach to doing that, and it's taking it back out to very close to its original shape. Now we'll go on then, and I'll show you how I'm going to do the repair here. Actually, there's two ways to go about this. And the first is to try to salvage the crushed leading edge, and I won't be able to tell if that's a worthwhile approach until after I get the covering taken off. Probably what I'm going to end up doing, though, is to splice in a new piece of leading edge and a new rib here in front of the main spar. So the first thing to do is to remove the covering so that I can see what the real extent of the damage is. Before I cut that covering off there, I'm going to take the iron and make sure that it's sealed down to the spar and to this rib, which is one bay away. Now I'm going to uncover it from here over to here. That'll give me this straight piece of undamaged leading edge then to use as a guide and for sanding and shaping the new piece that I insert. So we want to maintain the covering, make sure that it's stuck down all the way around the area where we're going to cut it off. Seal it down top and bottom, make sure that it's stuck good. Okay, that's stuck good. Now I'm just going to take a razor blade and cut out the covering, and so we'll come back and after I've gotten that straightened out and assessed the total damage. All right, I've trimmed around the hole with the razor blade, and I thought it might be interesting to see how I go about removing the covering. I use the sealing iron to just heat the adhesive and then peel it off. That way you leave most of the adhesive on the parts that are there, and you don't end up with excessive adhesives then when you recover it. Now the leading edge is probably the most difficult to uncover because you got quite a bit of area there. But I just heat it with the iron. You can heat right through double layers, and then just peel it back, and it peels right off. Okay, I think that, that shows you again the process, how I go about getting the covering off. And it looks as though that leading edge is shattered to the point where it's inappropriate to try and put it back together, although it could be done. The CA glues that we have nowadays are fantastic for this sort of thing. But I think what I'm going to do is go ahead and splice in a new piece of leading edge, and it looks like the rib is indeed crushed, but there's no damage apparent behind the spars, so I'll just cut this damaged rib off flush with the spars, sand it smooth, and then put a new piece of rib in between the spars and the new leading edge insert. So when I get ready to start doing that actual construction, we'll come back. Now we've got the covering trimmed off, and I have been able to assess the total extent of the damage, and there really is no damage except for the leading edge and this one rib. So I thought it might be interesting for you to see how I go ahead and trim off the broken material and make way for the new pieces that I'm going to insert. First thing I need to do is get rid of this front part of this broken rib stub. And what I'll use there is one of the fine saw blades that X-Acto sells that fits in an X-Acto knife handle. So I'll just let me get that around here so you can see what I'm doing. Just taking this saw blade, and I've put it in the handle so that the teeth cut when I'm pulling it back. That allows me then to make a real smooth, fine cut by pressing forward on it. And if I'm in a hurry, then I can pull it both ways, and it cuts. So we'll trim that off. And then we'll sand that smooth. Now we've got two more places to cut. I need to cut out the broken stub of the leading edge right here where it joins the leading edge of the tip, so that I have a place then to butt joint the new piece of leading edge in there. And then I also need to cut a taper on this good piece of leading edge here so that I can glue in the replacement piece of leading edge. And the way I do that, again, taking an X-Acto razor saw, this is the one with the real fine blade, and as I mentioned before, I want to use this as a guide in shaping the new piece of leading edge, so I will cut a taper in it such that I have as much of the shape as possible retained. So I'll just go ahead and I'll just saw down through that leading edge like that, and then I can pop it off of that rib. Now I'll have to clean the residue off the rib so that I maintain the dimension. And now the last thing to do then is to cut at the glue joint, and again I'm using the fine tooth